Welcome, everyone, to another edition of our Platform 9 hosted Kubernetes Fortnight. This session, we are talking about Calico networking in your clusters with Tigera. We are joined by Chris Tompkins that we'll introduce in just a sec. First, if you'd like to collaborate with us, if you'd like to talk, you can join our Slack, our Platform 9 Slack. It's a free offering, and you can go in the AMA channel, and we'll be there to speak with you. But probably more conveniently, right here in the webinar, you could post a message in the chat. We'll be watching it throughout. And if you ask a question, we'll cut in and get your question answered and chat about it. This is definitely an interactive session. We welcome all questions, all ideas. We love getting questions, and I think it just makes the session a lot more enjoyable if we can hear from you throughout the content. I have to do the mandatory plug here. If you'd like to create a free account and get your Kubernetes rolling, head over to platform9.com and you'll see a pink sign up button on there, and have at it. We've got all kinds of fun Platform 9 options in there, and Kubernetes options and things like that. You'll just plug in your infrastructure or your cloud account, and we'll get you rolling, ready for production. Right, so my name is David Dieroff. I am Developer Relations Manager at Platform 9, so I like to write code. I've been doing it longer than I'm going to admit. And today we are joined by Chris Tompkins. And Chris, I will hand it to you.
Yeah, hi there, David. Hopefully you can hear me loud and clear.
Yeah.
Great, fantastic. Yeah, hi. So I'm Chris Tompkins. I'm a developer advocate at Tigera, who are behind Project Calico, and my role is kind of to support the community and the contributors. So I've been doing networking for an awfully long time as well, longer than I would like to admit. So let's just both agree that we won't discuss that. 20 years, I'd say. 20 years I've been doing networking. And yeah, I kind of got interested in automation and kind of went from there to kind of Ansible and large infrastructures, and then ended up dealing with Kubernetes and got really interested in Calico and joined the team.
Cool. Awesome. All right. And so you've heard us say Calico a few times now, and we're going to talk about that. Some things that we're looking to cover today. We're going to lightly compare, I think, Flannel and Calico. I think Chris is going to give us a little bit of insight there. Quite frankly, it was a question that I've asked myself plenty of times. I kind of just ended up on Flannel, mostly because the person before me showed me that way, and so I did it. But then Calico, as I'm told, is a much better option for it, so I'd like to hear more about that myself. We're going to get deeper into Calico and its features. And then Chris is also going to get into some specific technologies, eBPF, VPP. We could come up with some more acronyms, I'm sure, but we'll let that go. And we're going to talk about performance, right? That's what it really comes down to.
Flannel and Calico solve the same problem in the sense that they both allow containers and pods and Kubernetes nodes to talk to each other. But Flannel does it with a VXLAN model, so which it encapsulates the traffic, and it does that in order to allow traffic to get between the nodes, no matter what the intermediary network looks like. So even if there's layer 3 hops and all that between, then that's how it gets across. But that's its only model, and it doesn't support network policy, so it just gives reachability. So you can kind of imagine it as enabling traffic everywhere, whereas Calico does more. Calico, I mean, it does significantly more, but it offers encapsulation in the same way, but it also offers alternative ways to encapsulate, and it offers the ability to turn off encapsulation altogether, which means that you're not wasting bandwidth because you haven't got a header on all of your traffic. But more significantly, it enables network policy, and you can kind of think of it as, well, if Flannel's letting all your pods talk to each other and all your nodes talk to each other. Calico's doing the same, but then giving you the ability to make sure that some of them don't, which is obviously really, really desirable, if you're trying to build a kind of zero trust networking model. So at the super high level, that's the most important thing is that it adds network policy and that it adds the ability to get traffic between the nodes in other ways. Does that make sense?
Yep, we're tracking.
Yeah, cool. Yeah. So so the other thing is, as well as that, I should mention that there's a performance comparison blog post, which I could actually show you, seeing as we don't have that many slides. We've gone minimal on the slides. Let me pull this up for you. So you should be seeing a browser window.
Yes, we are.
Great. Let me just pop this in here. Yeah, so this blog post is fantastic, and I really recommend people go and take a look at it. But this was taken in August 2020. We're hopeful of getting a new one soon. Alexis Ducastor, who's the guy who did this wonderful work, this kind of digs into a lot of detail about the actual performance of Calico versus Flannel. So that's a really, really desirable thing to dive into.
Chris, would you mind dropping that link in the chat, please?
Yeah, absolutely. Let me do that right now. If I can highlight my text correctly, I will. There we go. Yeah, there you go. I'm sure we probably have a mechanism to share afterwards as well, do we?
We do, yeah.
Yeah, fantastic. So I'll share that with you, and you can pass that on.
Okay.
So yeah, that's kind of two of the large elements. So different encapsulation, adds network policy, and not just Kubernetes network policy. You get an implementation of standard Kubernetes network policy, but you also get an extended feature set that Calico offers that you can choose to use or choose not to use, which kind of extends and enhances beyond what Kubernetes offers by default. The other thing is it offers features like encryption and multiple data planes. We'll dig into the multiple data planes thing in a moment, but basically you can just consider Calico to be kind of everything Flannel is in terms of features and significantly more. You don't have a limitation on IP pools because there is this middle ground you can use called canal, which is kind of a joining of taking the C from Calico and the rest of Flannel. You get a canal, which is the idea of using Flannel for your CNI and then using Calico's network policy. But even that is kind of a halfway house, and there's not really any advantage to doing that anymore. You get more moving parts, and you get no Calico IPAM, so you don't get the kind of IP address management functionality that Calico gives you. So yeah, I don't want to kind of to beat the drum too hard, but yeah, there's really not much reason to be using Flannel anymore, to be honest with you. We have a thing called the Tigera operator, which is a deployment tool for moving a cluster to Calico, and and I'll give you a link here for your attendees as well. But if you have a look at our install docs, I just dropped a link in there. There's a specific document describing how to get from Flannel to Calico. I'm just looking at the answers to your poll because that will give us an indication of how deep to dive. How familiar are we with? So that's interesting. Did you want to go over the poll results quickly, and then we can pick up from there?
Oh, whatever works. Whatever you'd like to do.
Yeah, well, that makes sense to me. So out of the replies we're getting most people saying they're kind of somewhat familiar with Calico. And does container networking matter? Yes. So the majority of people do have a spec that their customers must meet. And I would imagine that when you're deploying a Kubernetes cluster, the ability to implement network policy and the ability to encrypt traffic, those have got to be pretty critical, really.
Pretty big, yeah.
Yeah, exactly. And Calico offers both of those. Flannel offers neither. So So really, yeah. The other thing, when I was preparing this session and just thinking, is there anything else I should mention? The other thing to note is if you look at the actual commits on the GitHub projects, Calico is vastly more in development than Flannel is. Flannel still does get updates, but very few and far between. Did you want to drill into or speak more about the difference between them at a high level, or did you want? I could dive into a little bit about some of the cool features and the architecture of it.
Of
Calico.
Of Calico, sure. Yeah, let's get into it.
Yeah, cool. Okay. So you might. I'm going to put these slides up. One sec. I'm actually going to use this slide here, I think, which is from a different deck, but I think it's quite telling. So, so you've got a picture of a network node on the right-hand side of the slide there, and you can see you've got a control plane and a data plane element to that node. I don't know how familiar your attendees will be. Our attendees will be on that, but are you aware of the concept, David, of having a control plane and a data plane in the node?
Yes. Yeah. And I think the control planes, I think, are pretty common.
Yeah, exactly that. Yeah. So one of the reasons that I joined Calico, and one of the reasons I really like the product is that Calico is built on a control plane data plane model, and historically, when it was first deployed, or first designed, I should say, it has this four-tier architecture that you're seeing on the screen now. So you've got a data model, a calculation graph, and a data plane driver and a data plane. And essentially, what that means is that we talked about how Calico implements network policy and it implements reachability. Those things are implemented in the data plane, so that's where the forwarding happens. But the decisions, the calculations about how the network policy is actually defined, those happen higher up in the control plane. And Calico has multiple data plane options. So you have, on the left-hand side, you've got the traditional Linux IP tables data plane, which is the one that you get if you just deploy Calico today from from a kind of vanilla guide. What that means is that the reachability is implemented either in VXLAN or IP/IP or in BGP, depending on how you've got it configured. But the network policy is actually implemented in IP tables on the Linux host. You're familiar with IP tables, right?
Oh, yes.
Yeah. So IP tables that mode has advantages, and the advantages of it are essentially that it's battle tested. So you've got network policy being implemented in a tool that has been used for tens of years. The performance is really good. Our implementation of our policy in IP tables is heavily deployed. Lots of people are running it, and the security's tried and tested. And it also has very low requirements on the node. It doesn't need a new kernel version, so it's basically supported everywhere. So what I thought we could talk about today, or I'd like to talk about today, is the cool thing is that that's not our only choice. Because we separated out that control plane functionality and the data plane functionality, then you can implement the data plane can be implemented in whatever technology is available that can do that job well. I'm sure you've heard of eBPF.
So that one is, I'm briefly familiar with it, but it would be nice to kind of do.
Oh, great. Okay. Yeah. I'd love to actually. Yeah. So that's really interesting. Okay. So let's take a step back. So we've talked about what the let's just briefly talk about the Windows data plane as well, because it's a valid choice and there's reasons for choosing it. So let's kind of put a pin in that and talk about the Windows one, and then come back to eBPF because there's more detail there. So the Windows data plane is essentially a way to support Windows nodes. So it's an implementation of our data plane in Windows host networking. And the reason you would run it is specifically if you have Windows containers that need to be deployed and secured. So it's not a choice, you wouldn't make a choice between the IP tables data plane or the Windows data plane. You would choose whichever one based on your workloads, right? So with that said, let's talk more about the eBPF data plane, because that's the one where it's more of an interesting kind of comparison. So you have, recalling what we just said, the way the network policy is implemented, which is kind of allowing nodes and pods to either speak to each other or not speak to each other, that's implemented in IP tables rules in our IP tables data plane. But there are disadvantages of implementing an IP tables data plane, and the key one is performance. The performance is really good, but what eBPF actually is eBPF, it can be considered kind of a virtual machine technology for running a virtual machine in the kernel in the Linux kernel. So instead of writing your policy and running it in user space, you can actually run your network policy inside the Linux kernel, but without writing any kernel module. Because historically, to do that, you'd have had to have got a developer to write kernel code, and then you'd had to get your kernel code put through all the many hoops that you have to jump through in order to get code into the Linux kernel. So what eBPF is a way to run code inside the kernel that's sandboxed and verified, so it's trusted and secure. But it has the performance that you'd expect of code actually running inside the kernel. Does that make sense?
Yeah, I'm starting to see that. I mean, obviously performance, I mean, once you get closer to the kernel, right, performance is just going to continue to increase. I get it.
Yeah, and that's what's really cool. Not only are you close to the kernel, you're in the kernel. What actually happens, and this is I've done several other talks that if people want to dive, I'm trying to find the right balance of depth here, but there are other talks I've done. If you guys Google my name and look for there was a talk about the importance of multiple data planes, which is actually the one that we're looking at 1 or 2 slides from now. But there was also there's an eBPF deep dive blog. And yeah, I talk about this in quite a lot of detail, but in the eBPF deep dive blog, we talk about where you actually attach, and what's happening is you pre-compile this code and it's attached, it's placed inside the kernel, and therefore the performance is the kind of performance you'd expect of code running in the kernel. So that's not the only advantage here. Let me just show you that. So are you seeing a TCP connect time diagram? You are, right?
I am. Mm-hmm.
Great. Let me just pull up my notes. There we go. Yeah. So there are other advantages as well as just the raw performance numbers. Now, I've consciously excluded the raw performance numbers and from these slides, and the reason I've done that is because that linked comparison that I put in the chat that was performed by Alexis, who's a third party. And it's much more detailed than 1 or 2 slides. So if people are interested in the performance comparison, I'd say just what you want to know is that the performance is significantly better with our eBPF data plane. But if you want to see the exact numbers, I'd go and look at that. We just had an interesting comment. We just had a really interesting comment. If I'll read that out. It said, for some reason I'd misunderstood and assumed that Calico always used IP tables, and other CNIs like Cilium used eBPF, and that if you wanted eBPF, you'd have to use Cilium. So that's not the case at all, actually. This is something that I'm kind of banging the drum on because I think it's really important. What the guys did really well before I joined Calico, because I've been with the team kind of 6 months. One thing that excited me was that they made that distinction between the control plane and the data plane, and they did that from day one. And what that allowed them to do was to implement the things in the control plane that you want to write once, and you want them to work, and you don't want to review them 100 times because you just want to write that code and have it work perfectly. That's implemented in the control plane. And when you switch data plane in Calico from IP tables to eBPF, you don't switch the control plane. In fact, it's non-disruptive. Now, I'm going to put a massive asterisk on that and say, the documentation says it's non-disruptive, and when I've done it in labs, it is non-disruptive. But I personally wouldn't be switching the data plane on my live Kubernetes cluster, in production. I just don't see that's a great choice. But nevertheless, you could. So the reason I make that point is because what actually happens is that the data plane restarts and the code is then implemented in eBPF, and the control plane just takes over the control of the new data plane and everything carries on. And any new flow has its policy implemented in eBPF, and any old flow has its policy implemented in IP tables. But the cool thing is that means that we don't only have IP tables and eBPF. eBPF is great and everything, but it means that in the future, whatever technology comes along, we'll always be able to implement our data plane in it. And I think that's a really big deal. We'll talk a little bit later on about VPP, which is another data plane choice that we have that's in tech preview. And I think that's a really good illustration of the point. Does that make sense?
Yeah.
Yeah, cool. All right. Well, so what you're seeing on the screen is another one of the advantages. So as well as kind of the raw throughput advantage, you also get a TCP connect time advantage. Now, the reason this happens is because in a Kubernetes cluster, all of the services, node ports and so on, it's all implemented in Coop Proxy, which people will probably be familiar with, and that's how all of the services in a Kubernetes cluster happen. Now, Coop Proxy's implementation of services uses a list of rules that grows with the number of services. So the more services you have, the more rules there are. Those are implemented in IP tables again. But if you switch to IPVS mode in Coop Proxy, which is represented by the yellow line, you'll see that as you add more services, your latency doesn't increase. Your connect time latency doesn't increase, and that's because it uses IPVS uses a map lookup, and our eBPF implementation is also the same. It also uses a map lookup. So not only does it not get higher latency as the number of services increase, but as you can see, it's slightly lower than IPVS's latency in all cases anyway.
And it's I'm right to assume that in just a straight up, CNCF bland vanilla cluster, that comes using IP tables.
Yes, it does. Yeah. And one thing I haven't said very clearly is that Coop Proxy's implementation by default is in IP tables. It can be switched to use IPVS. But the reason that you're seeing our eBPF as a whole separate line here is what happens is that when the guys were implementing the eBPF data plane in Calico originally, there were some design decisions that meant that it made logical sense for them to re-implement the Coop Proxy functionality in the eBPF data plane. And that's what's happened. So when you actually enable the eBPF data plane on one of our clusters, you turn off Coop Proxy entirely. So you stop running those pods, which is cool because you also take away that complexity. Obviously your audience is really smart, and I would raise my hand at that point and say, well, yeah, you take away that complexity, but you add other complexity, and I think that's a fair point. That's totally a fair point, and that's why I call it out, because it's best to present things as best you can. But so that was a kind of a side effect, and replacing Coop Proxy's functionality meant that the same service functionality could be implemented in the eBPF data plane. Because it's happening inside the kernel, the performance is better, as you're seeing in this diagram. But the cool thing is they didn't stop there. So that's why I have these. Now, I'm conscious this is quite a detailed slide, but I think it's really worth drilling into. So
I have to say, Chris, that bringing my little bit of knowledge about this. I feel like I have just a little bit of knowledge,
Mhm.
but having looked at this slide earlier and just follow my the numbers through, this really spoke a lot to me. I mean, this really was like, yeah, okay, this is how this is working.
Yeah, exactly. And what's cool about this is now, having just gone through that description that we went through, remembering that, so we're saying that the eBPF data plane gets rid of Coop Proxy, but what we're seeing here first is how it works with Coop Proxy. So this is a vanilla cluster. Just to be clear,
Right.
this is a vanilla cluster. It could even be a Calico IP tables cluster, but either way, the services are still implemented in Coop Proxy. Now, what happens is your external client, which is your user or your guest service or whatever, needs to get to a service pod, but to do that, it needs to talk to a service. So you've got these 2 Kubernetes nodes at the bottom. This could be 100 Kubernetes nodes at the bottom, but the point is that you've got multiple nodes. And the external client hits the service IP address on the outside of the Kubernetes node. And Coop Proxy's job is to decide where the traffic should go, and also to make sure the traffic comes back through Coop Proxy, because that's necessary. So that's why it does both a source and destination source and destination NAT of the IP traffic. So the traffic then gets forwarded on. The pod responds to the traffic, and then the traffic has to go back through Coop Proxy and out to the client. Now, the key thing here is step 3. The pod that actually serves the traffic never sees the real source IP address of the traffic. It sees the source IP address of Coop Proxy. And what that means is if you have maybe a compliance requirement that means that your service needs to be able to see the user's real IP address because you're not allowed to offer a service outside of a certain country or something like that. The only way to implement that in this model is to not implement it on the service pod. So you can't tell your web server, your Apache server or whatever, that it mustn't respond based on the client's source IP address. The client has no visibility, and also in terms of audit trails, what ends up in the service pod's logs is the IP address of the Coop Proxy pod. Does that make sense?
Yeah, as I learn more, I know less,
Yeah, tell me about it. I think we all feel that way, though. I mean, I remember learning this stuff for the first time, and now I just have deeper questions. But yeah. So in contrast to that, what happens when you have eBPF is that the implementation of the Kubernetes services is still there, but it's not done in Coop Proxy anymore. So Coop Proxy is not running. There is no Coop Proxy. And you still have the same 2 Kubernetes nodes at the bottom. I'm pointing to them on the screen, by the way. I don't know why I'm doing that. It's not helping. But you can see that when the traffic originally comes in, instead of Coop Proxy making that decision, the BPF program makes the decision and decides where to send the traffic on. And it doesn't NAT the traffic. It doesn't need to. Once it arrives on the node that actually has the pod, it does a destination NAT, but only a destination NAT, no source NAT. And that's a necessary step, and there's no downside to that because that doesn't lose you any visibility. And then the pod serves the user. It sees the real source IP address of the traffic, which means that the logs on the server pod actually have the real details. Let's say you're running a VPN service, then you could restrict that to countries or whatever. And then the final step that's cool is if your network allows it, number 5 in the diagram, if your network allows it, the packet goes out directly back to the client. It doesn't need to go back through the ingress node, which obviously is less latency and less kind of unnecessary tromboning of traffic around the network. So this is a really big deal, actually.
If I could, Chris, I'm going to take a chance and ask possibly a dumb question.
No, go for it.
Because I I think I'm seeing the picture here, but I want to make sure. And with Coop Proxy, that running, so I'm going to be really basic here. Okay.
Yeah, no, go for it, love. Yeah.
As Coop Proxy is running as a pod, right? As it's a service running inside your cluster.
Yes.
Because this decision making has to go through that, you're going to see a little bit of latency, right? Because
oh, yeah, for sure. Yeah.
let's just put it so, like on every node, let's just say, how far are you from the kernel on every node, right? And if you're sitting inside a pod making decisions about network traffic, you're pretty far from it.
Yeah, exactly. At the end of the day, Coop Proxy is host networked, and so that means that but at the end of the day, it's still running in user space on the pod, and it's still well, not as a VM, but as a C group, I think it is, isn't it? Now I have to be careful not to bury myself with terminology here, but at any rate, yeah, it's what you said is great, because it captures the simple point that the further you get from the kernel, the worse your performance gets. I mean, it's that simple, right?
And it seems to me that as I'm looking at this slide right now with Calico eBPF, this is putting you closer to the kernel, because the decisions that are being made, I believe I'm seeing the decisions that are being made are more operating system centric, right? Which I say it that way because I mean you're just closer to the kernel making these decisions.
Yeah, absolutely. So the other thing to look at that's really cool about this is when you say, well, I'm just going to check. Yeah, we'll talk about that in a minute. Yeah, so I guess the key thing to think here is, okay, so well, hang on, why do we even have an IP tables data plane? Why don't we just do everything in eBPF? And one answer to that would be, okay, well, because eBPF, has been production ready for a certain amount of time, and Calico predates that. But there's a better reason, and that is that one tool isn't the right tool for every job. Now, eBPF, the ability to put the code into the kernel only comes with a certain kernel version, which I'm hoping you're not going to ask me to tell you off the top of my head. But
I wouldn't even know what to ask.
Yeah, well, there you go. That's very true. So the point is that if you have a brand new greenfield Kubernetes cluster that has a very recent kernel and you want to use BPF, then we're here for you, and you get amazing performance, and that's great, and happy days. But if you have what far more people have, which is a heterogeneous environment with, maybe you have this greenfield cluster up in one environment that does have a modern kernel, you can run BPF on that one. If you have an older cluster but you can't update it for whatever reason, we've all had that experience, that one you can continue to use IP tables, but your Calico implementation, your Calico network policy and so on is identical across both of those. And then we've got the Windows data plane support. So we're kind of, it's the best of all worlds, in my opinion. And if you look at, if you have a look at the performance graphs back on that link I shared right at the start, our eBPF performance is is excellent, and there's no real downside to choosing the tool that best suits your job. And what's really cool is we started off this conversation by saying that we've both been doing this a long time. We've both seen technologies come and go, and if for whatever reason something else appears that's better or different, there's no reason we can't support that in a very agile way and very quickly. Yeah, it's pretty cool.
Cool, thanks for that.
Yeah, I'm just looking at my notes just to make sure there's nothing more I should say. So I mentioned the kernel requirement, I mentioned the performance. Yeah, I did briefly allude to the live migration possibility. But what I'm just going to show actually here is we decided not to do a demo, but if you have a look at this is our eBPF, enabling eBPF data plane. This is basically our documentation on how to enable eBPF on a cluster that is already running Calico. And you can see that this helpful kind of plugin that tells you how long, this is a 12-minute read, so this is a really short thing. And that's the entire process, including you'll notice there's a reversing the process section here. So you can actually switch between data planes that easily. So it's really cool because it kind of allows you to benefit from the latest and greatest technology, but to support your environment, and to be able to roll back if you need to.
Let's hey Chris, let's take a minute and just kind of open it up.
Yeah, I think that's a great point to do so. Yeah.
Yeah, everybody's hanging out, listening to this. I hope you're maybe learning something, getting value out of this. But if you have any questions, right? If you're sitting here listening to this and there's something missing, or why do you do this, or what's the value of this, please don't hesitate to ask questions. We're here. You don't have to go deep. You don't have to be a professional getting into this. You can ask the simplest high-level question. All are welcome. And you have a moment with Chris, somebody that knows a heck of a lot more about networking and clusters than I do. So let's take advantage of this, having his attention. And we got a winner. Does Kubernetes or PMK or both have any notion of network policies in the absence of something like Calico?
Yeah, so it's really interesting, actually. I hope I get the detail right on this. But Kubernetes has network policies built in, but it has no implementation of them. So in a vanilla Kubernetes install, you can create network policies and they'll do precisely nothing. And that's because the CNI container network interface spec was designed with network policies in mind, but doesn't implement them by default. It leaves that to the CNI to offer that functionality. And Calico was a very early and very good implementation of that, which is why it's just one of the reasons for the popularity of it.
Would we be entering the world of admission controllers and things like that?
No, I'm gonna admit that my knowledge gets weak on admission controllers, actually.
Right.
So I don't think so, but I could be wrong. Can you elaborate on what you mean by that?
Well, I'm not going to get too deep here because I'm not going to put myself out of place either. But admission controllers, and I was just recently looking at OPA, that project, and they have a gatekeeper, I believe. And there were some ideas, but the thing that I don't remember, and I'm sorry for this, for mentioning it, is those admission controllers were specifically around the Kubernetes API, right? And not so much your custom applications or custom workloads running in the cluster. Mm-hmm. It was about limiting, who can do what with the Kubernetes API. So I may be a little out of place there.
No, I don't think so. But I think the way that it is done is that a vanilla Kubernetes cluster will have the resource type network policy, but they will do nothing. But you can create them; they'll just sit there, but if you were unlucky, they'd give you a false sense of security because they wouldn't actually be in any way implemented. They would just sit there and appear to be, I believe they would appear to be healthy. It's only when you put a CNI that understands what a network policy is onto the cluster, of which Calico is, is not the only one. But at that point, the network policies are then implemented. And you can think of that then as the control planes on the nodes then make the decision about how the policy needs to be rendered. That is to say that if you have a network policy that talks about a particular kind of pod, but none of those pods are running on 99% of your nodes, then that policy doesn't need to be on all those nodes. It only needs to be on the nodes that actually have that. So it's the control plane's job to render that policy down, decide where the policy actually needs to be implemented, and then it gets implemented on the node in whatever the data plane technology is that you've chosen to deploy, be that IP tables or eBPF or something else.
Okay. Ken followed up with this question here. Do you think of Coop Proxy always in the context of testing and development, or does it also provide sufficient controls for production grade applications? An example of port forwarding.
Yeah, I think Coop Proxy is definitely, it's definitely a totally valid thing to have in a production environment. 100%. It's just that in the event that you are on the eBPF data plane, then basically the need for it goes away. But the key thing is the need for Coop Proxy goes away, but the need for the features of the need to offer that functionality that Coop Proxy offers, that doesn't go away. That's why the eBPF data plane implements it instead, basically, but in a slightly advantageous way that allows us to have the direct server return and the source IP preservation and all those kind of things that we just talked about in the slides. So it's pretty cool. And then well, actually, I suppose we should see if there are other questions before we jump onto VPP. But
yeah, any other questions out there? Anybody got anything? Drop them in the chat. Otherwise,
Ken asked about PMK, and I think there's no distinction unless you know of something that I don't. Obviously, I don't work for Platform 9. Unless you know something that I don't, there's no distinction between Kubernetes or PMK in that way, right?
PMK in that respect, we're at kind of the same level.
Yeah,
we don't have any sort of control or anything over. Don't try to control anything over network policies.
Yeah, cool. So I can see already that we're going to run out of time, like we always do in these kind of things. But before we go on to other things, I should say that if you ever want me to kind of rejoin you guys and actually do a demo of switching the data planes, that is a really good demonstration in terms of actually getting an understanding of what's happening. And also, if you look on our Tigera blog, you'll find me rabbiting on about doing that and doing live demos of doing that on different platforms. Not on Platform 9, not on PMK, but on AWS and other things. So,
actually, I might take you up on that because that would make a great Twitch session.
Yeah, for sure.
Get on, share screen, and let's do this. See what happens.
Yeah, and I'll be totally honest with you. I really like to have, because I was trying hard not to have too many slides today, but I've ended up using more than I intended. And you kind of need something to structure talking around, don't you? Just a little bit. So be that a terminal or slides. And I think most techies prefer a terminal to slides, but yeah. Cool. All right, well, we can do that for sure. Yeah, it's my pleasure. So yeah, let's just talk offline and decide when might work for that.
Sure.
Any other questions before we move on from the BPF data plane? Doesn't look like it, does it? Yep. We can always take more. So to kind of jump on there for a second, there was this one other data plane that I alluded to early on, and it's in tech preview, and it's called VPP, vector packet processing. And this is a perfect example of how the ability to just plug in a new data plane allows anyone to try to do so. So there's a group called the FDIO project, and they wanted to plug in vector packet processing, which is another way of handling data plane forwarding. And I am not going to go into detail because I wouldn't do it as good justice as they would, but also because it's really deep. But broadly speaking, if the takeaway points are that, as well as eBPF, we have tech preview support for this data plane called VPP. When I first started experimenting with it myself, a bunch of things jumped out. It offers most of the same advantages that eBPF does. But one thing I noticed when we tested it internally is the IPsec performance is phenomenal, which basically means that we're going to run out of time to talk about it today, but we have WireGuard and IPsec encryption between nodes in Calico. WireGuard is a much leaner implementation of encryption, and so it's less lines of code and more performant and easier to audit and all those good things that WireGuard offers. But not everyone's allowed to use it because you might have some compliance regulatory requirement that requires you to use IPsec. And the VPP data plane, one of the things we noticed about it is that its IPsec performance is phenomenal. So that's kind of interesting. And I would obviously it's not ready for production clusters, but anyone who wants to knock it together and build a cluster now and see it running, that's totally doable. And I hope that when we start seeing third-party benchmarks, newer third-party benchmarks, the VPP ones will be in there for comparison. So I just literally got 2 slides to try to help understand what VPP actually is. Instead of taking each packet and running it through a packet processing graph, what VPP tries to do is to take a vector of packets. So if you have 100 packets in a row that need exactly the same treatment, then VPP is an implementation of that tries to take the largest possible vector of packets that it can and then chain it through the flow of nodes that you're seeing in the diagram. So maybe you have a DPDK input and then an Ethernet input and then an IP6 input and then an IP6 lookup. Rather than each packet going through that tree, they will all go through collectively as a chunk. The analogy I drew when I was trying to explain this in a session that was a bit more deep into this was it's kind of like baking cakes. If you had 100 cakes to bake, you wouldn't turn the oven on, ice one, put it in, bake it, take it out, turn the oven off, then ice the next one. You'd try and put as many in the oven as possible at once, right? And I think that's the best analogy. It's kind of a different paradigm for packet forwarding.
That is an amazingly good analogy, and now I want some cake.
Yeah, tell me about it. Yeah, I thought the same thing. I think, although I'm gonna play my own devil's advocate again and say, but there are plenty of examples of how, if you look at how cars are built, that doing all the steps one at a time at many nodes is also a perfectly valid way of approaching this. So I'm not. First of all, I didn't develop VPP, so I have no kind of no strong vested interest in saying it's sorry, I forgot to turn my Google Home off. But it's just a different approach, and it depending on your workloads and depending on your needs, I think the most important message is it's another solution that we offer, another data plane choice, and depending on what your needs are, not everyone's needs are the same. So if people want to know, we're nearly out of time, but if people want to know more about that, my colleague Casey and I think who was it? I actually don't remember. I think it was Casey did a FOSDEM talk about our VPP data plane support, and I did one as well. So if you Google Calico VPP, you'll find much more detailed talks about that data plane and what the advantages are and the strengths and weaknesses and all that kind of stuff.
Is the goal of VPP performance?
Yes. Yeah, it's extremely high performance and offers extremely good IPsec performance, as well as having the same set of advantages that the eBPF data plane does: source IP preservation. So yeah, broadly it is. Yeah, it's another option essentially.
Okay. Just really quick, I'm going to do a quick poll to everybody. I'd like to get a little bit of feedback on if you enjoyed the session, and we're reaching the time here, but I'd just like to hear from you. If there are other topics, sorry to cut in, Chris, I apologize.
No, you're fine. Go for your life.
If there are other topics or anything like that you'd like to hear, please drop us a line. You can drop it in the chat here. You can send me an email. You can go into our free Slack, whatever works for you. We'd love to hear from you. We're always looking for new topics. And I appreciate everybody answering the poll.
Yeah, I'll
Sorry,
actually
Chris.
run over. No, that's fine. I didn't actually join your Slack channel. I should have earlier in the day. So I'll dive over there in a second as well before I get distracted by
It's
other
all right.
things.
It's the chat is usually the most active.
Oh, is it? Okay, oh, that's fine.
Yeah, I keep an eye on it, and there's not much happening over there.
Oh, okay, that's cool. Cool. All right.
Yeah.
Well, yeah, let's talk offline about whether we can, do another session and actually demo that transition. And it may be that both for the people who are here today, it might solidify it to kind of see it actually done on a cluster. And then equally, if you get other people who show up who aren't here today, it's a good way of seeing it.
Yeah, I mean, if we could set up something that has live workloads, right? Just constantly hitting it, and then in the middle of that, you just switch over. That'd be pretty cool to see.
Yeah, definitely. So I think Sean Crampton, my colleague Sean Crampton, did a session that exists already on YouTube, which covers that. I'm not saying I don't want to do it. I'd love to do it. Totally happy to do it. And that's great. But just so if anyone can't resist and wants more BPF and they want it right now, then they can go and see that. They should be able to find that. I think that was a CNCF talk, I believe.
Okay.
Cool.
All right. Well, Chris, thank you very much for your time. I very much appreciate this. You've taught me something. I now have a little bit more understanding of what's going on between my pods in my cluster, and I'm a little scared by that, but it's okay.
Yeah. Well, this is how we all feel this way sometimes, don't we? About when I look at Kubernetes and I know my little piece of it and I understand my little piece of it, but there's an awful lot of stuff I don't fully grasp. But this is where it's great to have these kind of sessions.
There's an awful lot. You are right there. So awesome. I think we're at the hour. So thank you everyone for joining us, and watch our Twitter feed or our email newsletter. And in 2 weeks, we will be back at you for another session. Thanks, everybody.
Thanks, David. Take care.
Thanks, Chris. Bye.